Okay, here's the second part of 3.6. Still doing transformations of graphs of linear functions, and here I'm going to look at horizontal and vertical stretches and shrinks. Okay, in the first part we did translations and reflections. Okay, so a horizontal shrink, that is going to be a transformation that shrinks the graph towards the y-axis. Okay, so if you look at these two graphs below, we're going to do horizontal shrinks on both of these, which means that the points are going to get moved in towards the, if these points move in towards the y-axis, something like this is going to happen, okay? And with this one, these are going to move in towards the y-axis, so something like that is going to happen, okay? All right, and I'll get to those examples in a minute. But to do a horizontal shrink, you're going to multiply the input by a number, okay? And that number has to be greater than 1. If you use a number that's less than 1, it's actually going to be a horizontal stretch, which we'll get to on the next page. But a horizontal shrink is when you have a number greater than 1. So we call that number a often. And so if you look in both of these examples, the a value here is 2. So we're multiplying the input on both of these by 2, okay? So I'm not saying 2 times f of x. This is f of 2 of x. So we're multiplying, the input is the x, what's inside the parentheses, we're multiplying that by 2, okay? And then it says the horizontal shrink factor is the reciprocal of a, all right? So the reciprocal of a is going to be 1 over a. Reciprocals are two things that you can multiply together to get 1. So a times 1 over a would be a over a, which is 1, okay? You can think of it as flipping the fraction upside down. And now a isn't a fraction, but you could write it as a over 1, and then if you flipped it upside down, you get 1 over a, okay? And I'll talk more about what that factor means after I show you these examples, okay? So here I've got this is 2, okay? It's a number more than 1, so I know it's going to be a horizontal shrink. So then that 2 is going to determine how far these points go, all right? So these points, since that's a 2, I'm going to, graph is going to become twice as narrow. It's going to get sucked in towards the y-axis by a factor of 2, okay? So if you look at this top point, I'm thinking how far away is that top point from the y-axis? Right now it's 4 units away. So since this is 2, I'm going to take half that distance, so this point is going to move in like that, okay? And if I look at this point, it's 2 units away from the y-axis, so half of that would be 1, okay? And then I'm going to connect the dots, and I'll have my new graph. So this one would be f of 2 of x. F of 2x, I should say. Okay? So let's talk about the factor. So the factor is going to be 1/2. Okay? Because the reciprocal of 2 is 1/2. So if you look at the x coordinates here, we're really multiplying the x coordinates by 1/2. So that's why the factor is 1/2. So if you multiply -4 by 1/2, that's the same as dividing it by 2. And that means that this point is going to be -2, 2. So you see -2, if you multiply -4 by 1/2, you'll get -2. Same thing down here. This new point would be 1, -3. So if you multiply the x coordinate by 1/2, you get 1. So I just think of it as being twice as narrow, so you're going to move those in like that, okay? So on this next one, again, my factor is going to be the reciprocal of 2, which is 1/2. So these points are going to move in. That one's going to end up right there, because the original point was 2 units away, so that'll be 1 unit away. And down here, I'm 4 units away, so I take half of that, because the factor is 1/2. And there we go, okay? And then again, connect the dots here. Notice, by the way, on these, the point that's already on the y-axis stays there because that's 0 units away from the y-axis, so half of 0 is 0. So those points that are already on the y-axis with a horizontal shrink or a horizontal stretch on the next page are just going to stay in the same place, but all the other points will move. All right, so let's do some horizontal stretches then. So a horizontal stretch, that means that my points will be moving away from the y-axis. Okay, so with the shrink, they're moving in towards the y-axis. With the stretch, these points are going to move out away from the y-axis. And the only real difference here is that the number that's the A number is going to be something that's between 0 and 1. So if you look at this example, my A is going to be 1/2, okay? And over here, my A is 1/3. Okay? So to do a horizontal stretch, multiply the input again. We're multiplying the inside of the function, not the input. They're inside the parentheses, not on the outside. Okay? So it's a number between 0 and 1. You can think of it as less than 1, but we're not talking about negatives because a negative would give you a reflection, which is something different. So both of these numbers are between 0 and 1, and that means these points are going to move out. Okay? And when we're doing a horizontal, any horizontal movement, we're going to use the reciprocal of A. Okay? So I was kind of thinking about that example, so we're at 1/3, but 1/A, right, is the reciprocal of A. Okay? So if you think about multiplying these x's by something, that's going to move them left or right. So here the factor, so I'm thinking the reciprocal of 1/2, well, if you flip that fraction upside down, you get 2/1, which is 2, right? My factor here, if I flip 1/3, I get 3/1, which is 3. So that means I'm going to multiply these x values by 2, okay? So that means, another way you can think about it, it's going to double the distance from the y-axis. This is 1 unit away, so if I double that, now that's 2 units away, okay? This right now is 2 units away, so if I double that, my new point will be 4 units away from the y-axis. Okay? And if you think about the coordinates there, it's going to, and I also know that point. It's going to be on my line. But if I look at the coordinates here of those 2 new points, I've got 2, -3, which makes sense because I doubled the x, because that's what the factor is. And here, I doubled the x again from this one because the factor is 2. Okay? So far we've only used an A value of 2 or 1/2, but we can have other numbers there. So when we have a factor of 3, that means that these distances are going to triple. Okay? So it's going to get 3 times as wide if you want to think about it like that. Okay? So this point, my y-intercept is going to stay put, but these 2 points are going to move. So I'm looking at this and thinking, oh, it's 1 unit away. Let's triple that, which would be 3 units away. Not 3 units away from this point, 3 units away from the y-axis, which would put me here. Okay, because I want to triple this x value, which puts me at 3, 3 right there. And down here, if I'm tripling this x value, well, -2 times 3 is -6, so I get -6, -1, and that puts me right there. Okay, and then I've got enough points to draw my line. I suppose you could actually just move one of those points because you know what the y-intercept is going to be. It's the same as the original y-intercept. And then you can graph it with just using 2 points. But I wanted to show on these, yeah, these points are moving out when I have a horizontal stretch. Okay. Okay, let's look at some vertical shrinks and stretches then. So when we're looking at a vertical shrink, that means we're going to be moving these points towards the x-axis instead. So vertical movement would be movement up or down. So these points are going to move in towards the x-axis, okay, instead of moving towards the y-axis. All right. To do a vertical shrink, we're going to multiply the output by a number, okay? And so if you look where I've got the 1/2 here, and the 1/3. It's not in the input. The input would be inside the parentheses, but that's not where those are. So I'm multiplying the whole function by 1/2 or 1/3 here. So here my a value is 1/2, and here it is 1/3. Okay? These numbers are both numbers that are less than 1. They're between 0 and 1, and that's always going to happen when we have a vertical shrink. Okay? And then it's a little confusing because the stretch factor, we don't use the reciprocal when we're doing vertical shrinks and stretches. We just use the a value. So the vertical stretch factor is just going to be whatever a is, whatever you're multiplying by. So here the factor is going to be 1/2, just like the a value is. Here the factor is 1/3, just like the a value is. Okay. All right, so let's try out these examples. So when I'm going to change the height of these points, I need to change the y-coordinates. Okay, the x-coordinate here is going to stay the same, but the y is, on both of these is going to change. Okay, so this height right now is 4, and I'm looking at my factor is 1/2. So that means I need the new point to be half the distance from the x-axis. So it's shrinking towards the x-axis like this. Okay, and since the factor is 1/2, we'd be multiplying the y by 1/2. Multiplying by 1/2 is the same as dividing by 2, so this would give me the point -3, 2. Okay, this point is also going to move in towards the x-axis. Right now I can see it's 2 units away, so I want to take half of that. Since the factor is 1/2, means I'm multiplying my y value by 1/2, which would give me -1 for a y value here. Okay, and then on these ones, it lines up anyway, so you should be able to draw the line with just those, but it is going to keep the same x-axis because that point is already on the x-axis, so when it shrinks towards the x-axis, it just stays in the same place. Okay, and then I've got enough info to draw my line. Should really use a ruler to make it neat, but I'll do my best without. Okay, so this one is going to be 1/2 of f of x, which gives you a vertical shrink. Okay, all right, let's try another. Here my factor is 1/3, so again I'm going to be changing the y's, and I'm also going to be changing the height of those points by changing the y's. Okay, so since it's 1/3, these are going to come towards the x-axis. So I'm thinking, what's 1/3 of 6? Okay, so if I do 1/3 of 6, you can think of it like this. You can multiply it. 1/3 of 6, that would give me 6/3, which is 2. Okay, so it's really the same as dividing by 3. 6 divided by 3 is 2. So this new point would be right there. That's 1/3 of the height of the original point. So this would be the point 4, 2. Okay, and on this one, if I take 1/3 of -3, well, that's going to be -1. So I've got -5, -1 for my new point. Okay, the x-intercept will stay the same, and I can connect the dots. And there we go. Okay. All right. So let's look at some vertical stretches on the next page. All right, a lot of this works in the same way. Vertical stretches means these points are going to be moving away from the x-axis. Okay, so that's my first blank here, away from the x-axis. Okay, the big difference, one of the big differences is that this number is going to be a number that is more than 1, right? So my a value here is 2. My a value here is 3. Okay, and we're going to multiply again the output. It's not in the input. It's not inside the parentheses. So this is the output. We're multiplying the whole function by something. Okay, and the vertical stretch factor is a again. So if a is 2, that means the factor is 2. If a is 3, the factor is 3. All right, so let's try these out. So I'm going to be changing the y-coordinates of all of these points on both examples again because I want to change the height of those points. This time they're moving away, so I'm going to be multiplying all of those y's by 2 because I want to double this height. So I want that to be, instead of 2 units above the x-axis, I want it to be 4 units above the x-axis. So this would be the point 1, 4 as opposed to 1, 2. Okay? And then multiplying this y by 2, well, I want to double that vertical distance. So my new point will be at -4, -2. Okay. The x-intercept is going to stay the same. It should line up anyways if you draw a nice straight line. But I kind of like to just mark it to give me one more point to help me draw. Okay, and then I've got, this would be 2 times f of x that I just drew. All right, here my factor is 3, so that means that these distances are going to triple. The distance to the x-axis is going to triple. Okay, so multiplying 1 by 3 would give me 3, so this would be -5, 3. I'm not going 3 units up from this point, I'm going 3 units up from the x-axis. So this is -5, 3, and multiplying -2 by 3 gives me -6, so that would give me 5, -6. Okay, and the x-intercept, that point's already on the x-axis, so it can't get any closer to the x-axis or further away. It'll just stay there. Okay, and then connect the dots. And so here is 3 times f of x. Okay. Okay, this can get a bit confusing because we've got 4 different types of stretches and shrinks, and sometimes you multiply by the input, sometimes you multiply by the output, sometimes a is the same as the factor, sometimes it's the reciprocal. So I have this chart here to try to keep track of everything. Okay, so we've got our horizontal. These are our horizontal ones here and our vertical ones here, and we've got our stretches and our shrinks. So let's take a look at a horizontal stretch first. So this is one where the a value and the factor are reciprocals. We're going to be multiplying by the input. Okay, and so let's graph what a horizontal stretch would be like with a factor of 2. All right, so horizontal movement means left and right. So since this is a stretch, these points are going to be moving away from the y-axis. I'm just highlighting the y-axis to mean that's what I'm moving away from. Okay, so this other horizontal one, might as well, while I have this highlighter out, I'm going to be moving horizontally in towards the y-axis. Okay, for the vertical ones, I'm going to be moving my points up or down. So a vertical stretch would be moving away from the x-axis, and a vertical shrink would be moving towards the x-axis. Okay? Okay, so let's see. If we're stretching horizontally away from this yellow line, I want to double these distances. So we'd be multiplying the x values by 2. That's why the factor is 2. So it's 1 unit away from the y-axis. So now it's 2 units away. This one's 2 units away, so we'll make that 4 units away. And the same thing down here, doubling the distance of all those points from the y-axis. Okay. Okay. This one I'm going to be, since it's shrinking horizontally, they're moving in towards the y-axis. So my factor is 1/2. That means I'm going to take half of these distances. So half of this is 2 units away, half of that would be 1, and then half of 1 is 1/2. Okay, and the same thing happens down there, taking half of those distances. It means I'm going to be multiplying the x values by 1/2. That's why my factor is 1/2. Okay, so those are moving in towards the y-axis. Okay. All right, and then our vertical changes, a vertical stretch. So these points will move away from the yellow line. So that means that the height of these points is going to double. So now that's 2 units above the y-axis. So this is already 2 units above, so that will become 4 units above. The same thing will happen with these points. They'll move down and double their distance from the y-axis. So you'd be multiplying the y-coordinates by 2 to change the height of those points. Okay? And changing the height again, but this time, since it's shrinking vertically, that means these points are all going to move in towards the y-axis. So I'm going to take half of this height, which is 1. That's why my factor is 1/2. I'd multiply the y-coordinates by 1 to achieve this. And there we've got a vertical shrink. Shrinks are sometimes called compressions. Some books might call them compressions. I call it that sometimes on accident. Okay, that's the end of the section, and I'll see you next time.